Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. Today we study the chapter Binomial Distribution from Mathematics paper 2nd. This is the first lecture for this chapter. Now in this chapter we have to study a main concept that is called as an Bernoullis Trial. Now first, what is the trial? Trial means to make any experiment once. To make any experiment once only. Means suppose we toss a coin. We toss a single coin. Or we toss a disc. Or we say die. We select one card. That is an experiment which is performed only once. It is called as a trial. For example, tossing a coin, tossing a disc, etc. Now next is Bernoullis trial. Now consider a trial. In which we get only two outcomes, or we considered only two outcomes. One is a success and second is a failure. For example, suppose we toss a die. So the outcomes of that random experiment is 1, 2, 3, 4, 5 and 6. Now if we define here X, that is the success, as getting odd number. So this is X is denoted by success. Suppose it is the success, then what will be the failure? Second one is failure becomes getting even number, or you can say that getting non-odd number. So getting even number is a failure. You observe that if we consider any one of the outcomes, suppose we consider 2, then it is either in success or in failure. 2 is the even number. We consider success as getting odd number, so it goes to the failure. And if we consider 5, it goes to the success. Such a trial is called as an Bernoullis trial. Such a trial is called as an Bernoullis trial. Means a trial in which number 1 we get exactly two outcomes, which are they? They are success and failure. Yes for success, F for failure. That is, we get only two outcomes, that is the success and a failure. This is the first condition. And the second condition, the success and the failure remains the same in each trial. That means the probability of success, getting success or getting failure are same in each trial. Such a trial is called as an Bernoullis trial. Now in Bernoullis trial, the probability of success is denoted by small p. That is, we write here small p equals to probability of success. Now, in Bernoullis trial, we say that it consists only two outcomes. It consists only two outcomes. One is a success and second is a failure. And if we denote Q equals to probability of failure, then this success and failure together, we get the sample space, yes. We get sample space, yes. And we know that the probability of a sample space is always 1. So we get the result, that is P plus Q equals to 1. We get the relation between probability of success and probability of failure is, that is the P plus Q equals to 1. Now next, if this Bernoullis trial repeat n times, this Bernoullis trial repeats n times, then to find the getting R success or getting X success, we write the probability distribution, which is called as binomial distribution. Now that binomial distribution is defined as, let's see, the binomial distribution. Now suppose P is the probability of success, P is probability of success, Q is probability of failure, probability of failure. And suppose this Bernoullis trial is repeated n times, that is we take the n trials, we get n trials, then that variable x, which is defined for a success, a discrete random variable x is defined for a success having probability distribution. If it having probability distribution, that is probability of x equals to small x, this is the value of x, equals to ncx p raised to x into q raised to n minus x. If this is an PMF, probability mass function, or we say that probability distribution, then we say that this random variable x follows the binomial distribution. This random variable, discrete random variable, follows the binomial distribution, and it is denoted by, that is x follows binomial distribution over n and p. X follows binomial distribution over n and p. Here this n and p are called as the parameters, because if you know the values of n and p, we can find any probability, or we can find the probability for any value of x. So here this n and p are called as an parameter for the binomial distribution. Parameter for the binomial distribution. So now we get the definition of that binomial distribution. Now by using this formula, we solve some examples from exercise 8.1. Some examples from exercise 8.1. So now exercise 8.1, question number 1. From exercise 8.1, the first question is, question number 1, a die is thrown 6 times. A die is tossed or throw, is tossed or thrown 6 times. 6 times. If getting odd number, if getting odd number, getting odd number is a success, is a success, then find the probability. Find the probability. Now sub question number 1, we have to find the probability that 5 successes number 2 at least 5 successes, at least 5 successes, and number 3, there are 3 sub questions. Number 3rd is at most 5, at most 5 successes. Now here consider a trial. First consider and trial of tossing a coin or a disc. Consider a trial of tossing a die. We know that the sample space of tossing a die is 1, 2, 3, 4, 5 and 6. Clearly here n of s is 6. N of s is 6. Now if we define A as odd number, then A is 1, 3, 5. So n of A becomes 3, and therefore by definition probability of A equals to n of A upon n of s. We get 3 upon 6, which is equals to half. And we define that getting odd number is a success, and here we find the probability of getting odd number is 1/2. That is, here we know that we define the probability of success by small p, so we get small p equals to 1/2. Small p equals to 1/2. Now by using the relation, since we know that P plus Q equals to 1, which implies that Q equals to 1 minus P, we get Q equals to 1 minus half, that is equals to half. So finally we get Q equals to half. We get these two values, that is P half and Q is half. Now also given that disc or that die is thrown 6 times. It means that trial is repeated 6 times. So we write n equals to 6. N equals to 6. That is, we get all the parameters. That is, writing again, that is, we get P equals to 1/2, Q equals to 1/2, and n equals to 6. N equals to 6. And the probability distribution of a binomial distribution is P of x equals to x is NCX P raised to x into Q raised to n minus x. Give it is an equation number 1. Give this is an equation number 1. Now we solve these sub questions. Now sub question number 1. Now in sub question 1, we need 5 success. Question number 1, that is 5 success. So here we take x equals to 5. We take x equals to 5. Now putting the value, this value in equation 1, therefore by equation 1, we get probability of x equals to 5 equals to 6c5 1/2 raised to 5 into 1/2 raised to 6 minus 5. And this 6c5, see here, this 6c5 can be written as 6c 6 minus 5, that is 6c1. We know that NCR, since NCR is equivalent to NC N minus R. So this 6c5 is equivalent to 6c1, and we know that NC1 is always N. So here this 6c5 equals to 6 only. 6c5 equals to 6 only, and this, here it is 1/2 raised to 5 as it is, and this becomes 1/2 raised to 1. 6 minus 5 is 1. Now this becomes 6 upon 2 raised to 6 by using law of indices. Now put the value of 2 raised to 6. That is 64. 2 raised to 6 is 64. Dividing by 2, we get probability of x equals to 5 is 3 upon 32. We get the probability of getting 5 success is 3 upon 32. Now the second sub question. Now in second sub question, we have to find getting at least 5 success. Success. So number 2, getting at least 5 success. That is, x must be greater than or equals to 5. Because we have to find at least 5 success, means the possible values are 5 and 6, that is greater than 5. Actually the values are x must be greater than or equals to 5, but we toss the disk in 6 times only, so we cannot get the more than 6 success. So this is probability that x is greater than or equals to 5 is equals to probability of x equals to 5 plus probability of x equals to 6, since x is a discrete random variable. Now putting this value in equation 1 again, putting the values of x and other known values in equation 1, we get probability of getting x is greater than or equals to 5, that is getting at least 5 success, is given by 6c5 1/2 raised to 5 into 1/2 raised to 6 minus 5. This is for getting 5 success, plus now for getting 6 success, put x equals to 6. We get 6c6 1/2 raised to 6 into 1/2 raised to 6 minus 6. 6 minus 6. Now again here we say that see that NC5 or 6C5 is 6. Similarly here this 6C5 again it becomes 6. Now this becomes 1/2 raised to 5 into 1/2 raised to 1, 6 minus 5, 1. Now NCN, we know that NCN is 1 always. So here it is 6C6 means it is 1. So here into 1/2 raised to 6 into 1/2 raised to 0. 1/2 raised to 6 into 1/2 raised to 0. So now making these calculations, this becomes 6 into 1/2 raised to 6 plus 1/2 raised to 6 by using law of indices. Now taking 1/2 raised to 6 as a common factor, we get 6 plus 1 into 1/2 raised to 6. 1/2 raised to 6. So we know that this 2 raised to 6 is 64. So we get 7/64 because 6 plus 1 is 7. So we get probability that x is greater than or equals to 5. That is getting at least 5 success. It is found to be 7/64. Now the third case, that is getting at most 5 success. Getting at most 5 success. Now to find the probability that getting at most 5 success, remember one thing, the value of x here, that is the getting successes, are 0, 1, 2, 3, 4, 5 or 6. Since we tossed the disk 6 times, so the only possible values of x are 0, 1, 2, 3, 4, 5 and 6. This is the indirectly the sample space for the value of x. Now here getting at most 5 success, that is we have to find probability that x is less than or equals to 5. X is less than or equals to 5. Here x is less than or equals to 5 means the value of 0, 1, 2, 3, 4, 5. These 5 values of x are allowed. These 6 values of x are allowed. It also means that the value of x equals to 6 is not allowed. So this probability of x is less than or equals to 5 can be written as 1 minus probability of x is greater than 5. X is greater than 5, since we know that probability of a complement equals to 1 minus probability of a, or we can say or write, that is probability of a equals to 1 minus probability of a complement. Here 1 is the probability of an sample space. By using this formula, we can write probability of x is less than or equals to 5 equals to 1 minus probability of x is greater than 5. Now the only value which is greater than 5 is 6. The value of x which is greater than 5 is 6. So this can be written as 1 minus probability of x equals to 6 only. This is the probability of 1 minus probability of x equals to 6. Now putting in equation 1, put this value in this equation. So we get probability of x is less than or equals to 5, which is equals to 1 minus 6c6 1/2 raised to 6 into 1/2 raised to 6 minus 6. So this gives 1 minus. Now we know that NCN, NCN is 1. So here 6c6 is 1 into this 1/2 raised to 6 into this 1/2 raised to 0. Now if we use the law of indices, this probability of x is less than or equals to 5, it becomes 1 minus 1/2 raised to 6. 1 minus 1/2 raised to 6, and we know that 1/2 raised to 6 means 1/64. So we get probability of x is less than or equals to 5 equals to 1 minus 1/64. Taking cross multiplication, it gives 64 minus 64 minus 1/64, that is 63/64. So probability of getting x is less than or equals to 5, that is probability of getting at most 5 success. At most 5 success is 63/64. Now in next lecture we continue the exercise 8.1 from example number 2. Thank you.